Welcome to the lesson on simplifying expressions. This is a review lesson, so we are going to just briefly talk about a couple of topics with simplifying expressions. If you need additional help, please look up the resources provided on the resource page at the website. There are videos from Khan Academy that can address each of these topics in a little bit more detail. You can also ask questions on the main lesson page, and I will respond as soon as possible. All right, let's go ahead and get started. When looking at simplifying expressions, the first thing we want to look at is order of operations. It's important to know the correct order of doing our operations. This is agreed upon within the math community. So the first thing we want to address is the grouping. Grouping mechanisms include parentheses, brackets, fraction bars, and radicals. Brackets are squared parentheses. Fraction bars group our expression into both a numerator and a denominator. And then radicals, we have to take care of the operation inside of the radical before applying the radical itself. After we look at grouping, we can address exponents, which are a level 4 operation. Remember that radicals are also included in exponents. Radicals are exponents raised to a fraction. Then we look at level 3 operations, which is multiplication or division, whichever comes first. Then we address level 2 operations, which is addition or subtraction, whichever comes first. Let's take a look at a couple of examples. First, I have 0 minus 24 over 6 divided by 2. Here we see the fraction bar working as a grouping mechanism. We have the numerator as a group and the denominator as a group. We need to simplify the numerator and denominator before we use the fraction bar as division. So for my numerator, 0 minus 24 is equal to negative 24. The denominator, 6 divided by 2, is 3. So I get negative 24 over 3. Now, since both numerator and denominator are simplified, I can now use that division bar, or that fraction bar as division. Negative 24 divided by 3 is negative 8. Next, we see the fraction bar again working as a grouping mechanism. I want to simplify my numerator, simplify my denominator, and then use the fraction bar as division. So for my numerator, the first operation I'm going to address is the multiplication. The second operation I will address is the addition. In the denominator, the operation that I have is an exponent, so I'm going to simplify that. For my numerator, 3 times 6 is 18, so I get 2 plus 18. For my denominator, 2 squared is 4. Now address the addition in the numerator. 2 plus 18 is 20 over 4 is equal to 5. Next, we see negative 44 is equal to negative 44 divided by the square root of 12 divided by 3. Here we see the radical working as a grouping mechanism. I need to take care of the division inside of the radical before I apply the radical itself. 12 divided by 3 is 4. So I see negative 44 divided by the square root of 4. As far as order of operations are concerned, I take care of level 4 operations before level 3 operations. A square root is a level 4 operation, division is level 3. So we have negative 44 divided by 2. Negative 44 divided by 2 is negative 22. Let's take a look at the distributive property next. The most common representation of the distributive property is a product of a sum is the sum of products. Here's a visual of what that statement says. A product of a sum. So a product is multiplication, sum is addition. So we have 5 times the quantity of 8 plus 7. When I see something like this, I can distribute the multiplication to each part of the addition. So 5 gets distributed to 8 and 5 gets distributed to 7 connected by multiplication. So 5 times the quantity of 8 plus 7 is 5 times 8 plus 5 times 7. We also see it where we have subtraction on the inside of the parentheses. So we have 9 times the quantity of 4 minus 1. So we can distribute the multiplication of 9. So 9 times 4 minus 9 times 1. Now what I really want us to focus on is the level of the operations that are occurring. So for our first one, we have 5 times the quantity of. So the operation on the outside of the grouping is multiplication. That's a level 3 operation. On the inside, we have addition. So we can distribute a level 3 onto a level 2. That holds true for our second example, where I have 9 times the quantity of 4 minus 1. The operation on the outside is a level 3. The operation on the inside is a level 2. If we take a look at this, we have the quantity of 4 plus 8 over 2. I say the quantity of 4 plus 8 because my fraction bar is working as a grouping mechanism. So 4 and plus 8 is a group itself. So outside of the group, we are dividing by 2. That's a level 3 operation. Inside of the group, we have addition. That's a level 2 operation. So I can distribute my level 3 operation onto each part of the level 2 operation, which gets me 4 over 2 plus 8 over 2. If I look at doing this by order of operations on both the left and the right-hand side, I do get the same value. So on the left-hand side, I have 4 plus 8 is 12, divided by 2 is 6. On the right-hand side, I have 4 over 2 is 2, plus 8 over 2 is 4. 2 plus 4 is 6. We also see the distributive property when we look at exponents. So we see a power of a product is the product of powers. This means that a power, which is a level 4 operation, can be distributed onto a product, which is a level 3 operation. So let's take a look at an example of that. Here I have the quantity of 5 times 4, which is a level 3 operation, raised to the third power, a level 4 operation. So I can distribute level 4 onto level 3. So we end up with 5 to the third power times 4 to the third power. This also works when we have variables. Here I have the quantity of 2x raised to the fourth power. The operation linking 2 and x is multiplication. So anytime we don't see it, we know it's multiplication. So on the inside of the parentheses, we have level 3. On the outside, raised to the fourth power, we have a level 4. So I'm going to distribute that fourth power to each part of the multiplication. So we get 2 to the fourth power times x to the fourth power. Remember that a square root is also a level 4 operation. So when I see the square root of 4 times x squared, inside of the square root we have a level 3 operation, multiplication. Outside, the radical itself is a level 4 operation. So I'm going to distribute that level 4 operation to each part of the multiplication. So we have the square root of 4 times the square root of x squared. Here we see an example where the level 3 operation is division and the level 4 operation is an exponent. The same rules apply. We can distribute a level 4 operation onto a level 3 operation. So we distribute the cube to the numerator and denominator, so we get 1 to the third power over 4 to the third power. We can also apply this with a radical and a fraction as well. Inside of the radical, we have division, which is level 3. The radical itself is a level 4 operation, so we distribute the level 4 operation to each part of the level 3 operation. So the square root of 4/9 is equal to the square root of 4 over the square root of 9. Next, we're going to talk about our exponents and our exponent rules. First, let's start off with zero exponent. Any non-zero number raised to a 0 power is always equal to 1. For example, 8 raised to the 0 power is equal to 1. So 8 is a non-zero number and it is being raised to the 0 power. Next, we see the quantity of 1/5 raised to the 0 power. That's going to equal 1. Now, note that when we have 0 raised to the 0 power, this is undefined. right? This does not exist on our number line. Next, let's talk about negative exponents. When I have a negative exponent, we want it to switch levels. So for example, if I have 2 to the negative 4th power, I want it to go from a numerator into a denominator so that it can become positive. So 2 to the negative 4th power is 1 over 2 to the 4th power. 2 to the 4th power is 16, so I have 1 over 16. If we have negative 3 to the negative 2 power, I want to make that into the denominator. So we have 1 over negative 3 to the 2nd power. Negative 3 to the 2nd power, here we see the negative sign inside of the parentheses. So the negative is included in the base, which means we have negative 3 times negative 3, which gets us to positive 9. So we get 1 over 9. Our next example, we have 2 over w to the negative 5th power. Right now, w to the negative 5th power is in the denominator. To make the exponent positive, we want to move it to the opposite level, the numerator. So it becomes 2 times w to the 5th power over 1. Anything over 1 we can write as itself, 2 times w to the 5th power. Next, we see y to the negative 8th power over w to the negative 2 power. Both of these exponents are negative, so we want both of the quantities to switch levels. This becomes w to the 2nd over y to the 8th power. Next, we're going to take a look at multiplication properties of exponents. Our first property of exponents that we're going to look at is power of powers. So here, when I have the quantity of x squared raised to the 3rd power, it ends up being x to the 6th power. So when I have the situation where we have an exponent being raised to another power, we end up multiplying. So 2 times 3 is equal to 6 for our exponents. We can look at where this comes from. If I have x squared raised to the 3rd power, that means x squared times x squared times x squared. Now each x squared is x times x. So for my first quantity, it is x times x, second quantity times x times x, third quantity times x. So all together, we have 6 x's being multiplied together, so we get x to the 6th power. So when we have power of powers, we multiply our exponents. When we have a product of powers, like x squared times x cubed, we add our exponents. So the exponent of 2 plus the exponent of 3 gives me an exponent of 5, x to the 5th power. We can explore where this comes from as well. If I have x squared times x cubed, my first product is x squared. This consists of x times x. Then we have times x cubed. This consists of x times x times x. So all together we are multiplying 5 x's, which is x to the 5th power. Here are a couple of examples. Here we have b to the 4th to the 6th power. This is power of powers, so I multiply my exponents. 4 times 6 is 24, so this is b to the 24th power. Next, we have x to the 4th raised to the negative 2 power. This is power of powers, so I'm going to multiply my exponents. 4 times negative 2 is negative 8, so we get x to the negative 8th power. I always want my answer to be in positive exponents, so I'm going to move that x to the negative 8th to the denominator and make it positive. We have 1 over x to the 8th. Negative 4 x cubed raised to the 2nd power. Now here we see the distributive property. Inside of the parentheses, we have negative 4 times x cubed. That is a level 3 operation. Outside of the parentheses, we have to the 2nd power. That's a level 4 operation. So I'm going to distribute the square to each part of the level 3 operation. So I get negative 4 squared times x cubed squared. Negative 4 squared is negative 4 times negative 4, which is positive 16. X cubed squared is power of powers, so I'm going to multiply my exponents. 3 times 2 is 6, so I get 16x to the 6th. Next we have xy times x squared raised to the 3rd power times y cubed raised to the 4th power. So this is a combination of power of powers and product of powers. If I take a look at the first product, the first part, we have x to the 1st power times y to the 1st power. Then if I take a look at the second part, I have x squared cubed. So this is power of powers, so I'm going to multiply my exponents. 2 times 3 is 6, so I get x to the 6th power. Then we have y cubed to the 4th power. This is power of powers, so I'm going to multiply my exponents. 3 times 4 is 12, so I get y to the 12th power. Now I want to do the product of powers. So remember that multiplication is commutative, which means I can switch the order. So in my mind, I'm going to think of it as multiplying my x's together first, then multiplying my y's together second. So x to the 1st power times x to the 6th power, I'm going to add my exponents. 1 plus 6 is 7. So I get x to the 7th power. Then I'm going to take a look at my y's. I have y to the 1st power times y to the 12th power. 1 plus 12 is 13, so I get y to the 13th power. Next, we're going to move on to the division of exponents. So to explain the division of exponents, we're first going to look at an example. If I have 5 to the 8th power divided by 5 to the 6th power, 5 to the 8th power is 5 times 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 5. That's 8 5s being multiplied together. In the denominator, we have 5 to the 6th power, which is 5 times 5 times 5 times 5 times 5 times 5. There are 6 5s being multiplied together. Now, when we have multiplication and division, those two operations are inverses and therefore cancel. So what we can do is think of 5 over 5 as equal to 1. 5 over 5 equals 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 1. Now, each of these that has the red dash through it is the equivalent of the number 1. So when I multiply 1 times 1 times 1 times 1 times 1 times 1, that is still equal to the number 1. And if I were to multiply 1 times 5, that still equals 5. So the reason why we say that they cancel is because they become the number 1 and then get absorbed into the other numbers. So what I'm left with is 5 times 5, which is 5 to the 2nd power. Now if we look at the relationship of our exponents, we start off with 5 to the 8th over 5 to the 6th. And to get 5 to the 2nd power, we can take the exponent from the numerator and subtract the exponent from the denominator. So it's going to be 5 to the 8 minus 6th power, which is 5 to the 2nd power. So our quotient of powers, quotient means division, is if I have x to the 5th over x to the 2nd, I subtract my exponent from the numerator minus the denominator. So x to the 5 minus 2, which equals x to the 3rd. All right, let's take a look at simplifying a few using the quotient rule. If I have 3 to the 7th over 3 to the 3rd, that is going to be 3 to the 7 minus 3, which is 3 to the 4th. 3 to the 4th is equal to 81. If I have y to the 10th divided by y, remember that in the denominator, if I don't see an exponent, it's to the 1st power. So it's y to the 10th over y to the 1st. So it's going to be y to the 10 minus 1, which is y to the 9th. Here we see 2 to the 5th times 3 to the 7th over 2 to the 7th times 3 to the 6th. Now with these exponent rules, we have to have the same base. So I'm going to focus on my 2's, and then I'm going to focus on my 3's. So if I focus on my 2's, I'm going to have 2 to the 5 minus 7 power. If If I focus on my 3's, I'm going to have 3 to the 7 minus 6 power. Now here I see a negative exponent. I get 2 to the negative 2 times 3 to the first power. So 3 to the first power is going to stay in the numerator. 2 to the negative second needs to move to the denominator. So I have 3 to the first over 2 to the second. 3 to the first is 3, 2 to the second is 4. All right, now we're going to take a look at power of a quotient. So here we can see that the order of the words has changed. First we had quotient of powers, which means that we were dividing, each our numerator and our denominator had exponents. Now we're going to switch it around. So this is what a power of quotients looks like. So inside of the parentheses, we have division. Outside of the parentheses, we have a power. Now we address this with the distributive property. We are going to distribute the power to the numerator and the denominator. So the quantity of x over y raised to the 5th power is equal to x to the 5th power over y to the 5th power. A couple of examples. If I have the quantity of 2 over 7 raised to the 2nd power, I'm going to distribute the power of 2 to the numerator and the denominator. So I get 2 to the 2nd power over 7 to the 2nd power, which is equal to 4 over 49. Here I see the quantity of 2x over y to the 3rd power raised to the 3rd power. So I'm going to distribute that power of 3 outside the parentheses to the numerator and the denominator. So I get the quantity of 2x raised to the 3rd power over the quantity of y to the 3rd raised to the 3rd power. Now in the numerator, we see the distributive property again. Inside the parentheses, we have level 3 operation, which is multiplication. Outside a level 4 operation, so I need to distribute the cube to the 2 and to the x. So in my numerator, 2 to the 3rd power is 2 times 2, 4, times 2, 8. So we get the numerical value of 8 times x to the 3rd power. In the denominator, we have power of powers, so we multiply our exponents. 3 times 3 is 9, and we get y to the 9th in the denominator. Next, let's take a look at negative power of quotients. To talk about this, we're going to go over a couple of examples. So if I have the quantity of 3 over 4 raised to the negative 2 power, what I want to do is switch the levels because of that negative exponent. So this becomes 4 over 3 raised to the 2nd power. I want to distribute that 2nd power to the numerator and denominator, so I get 4 to the 2nd power over 3 to the 2nd power, which is equal to 16 over 9. Next, if I have 2x over y cubed raised to the negative 4th power. To take care of that negative component of the power, I want to take the reciprocal, switch the levels of the quotient inside the parentheses. So I get y cubed over 2x raised to the 4th power. In my numerator, I see power of powers when I distribute that power of 4. So 3 times 4 is 12. So in my numerator, I get y to the 12th power. In my denominator, there are 2 parts of the denominator, 2 times x. So the power of 4 needs to go to the 2 and get distributed to the x. So 2 to the 4th power is 2 times 2, that's 4, times 2, that's 8, times 2, that's 16. So our numerical value is 16, and then we have x to the 4th in the denominator. So in the end, we get y to the 12th over 16x to the 4th. Again, if you have any questions about anything that's we've covered in this mini lesson, please go to the main page for the lessons, scroll down, and you can add a comment onto the chalkboard, and I'll get back to you as soon as possible. You can also look up more videos that has to do with these topics by going to the resource page on this website. All right, thank you.